Hi there. Welcome to our channel Stuff About Stuff. Today we discuss what is TCP IP, the beginner's guide to TCP IP. We will cover the basics of this important protocol and how it powers the internet. Part 1, the basics of TCP IP. Welcome to part 1 of our exploration of TCP IP, or Transmission Control Protocol and Internet Protocol. In this section, we'll be covering the basics of this important protocol and how it works. We'll start by defining TCP IP and explaining its role in allowing devices to communicate and exchange information over a network. We'll also discuss the two main protocols that make up TCP IP: the Transmission Control Protocol, TCP, and the Internet Protocol, IP. By the end of this section, you should have a solid understanding of the basics of TCP IP and how it powers the internet. Let's get started. First, let's define TCP IP. TCP stands for Transmission Control Protocol, and IP for Internet Protocol. Together, they form the basis for how data is transmitted and routed across the internet. TCP IP is important because it is the foundation of the internet. TCP IP enables communication and data exchange between devices. Without it, the internet as we know it would not be possible. It allows us to send emails, access websites, use social media, and perform countless other tasks online. TCP IP is also important because it allows devices to connect and communicate with each other regardless of their location or operating system. TCP IP is a universal protocol that enables the internet to be a global network. In short, TCP IP is vital for the smooth functioning of the internet and plays a crucial role in our daily lives. The role of the Transmission Control Protocol and the Internet Protocol. The Transmission Control Protocol, TCP, and the Internet Protocol, IP, are the two main protocols that make up They work together to allow devices to communicate and exchange information over a network. The Transmission Control Protocol, TCP, is responsible for ensuring the reliable transmission of data between devices. It does this by breaking down large chunks of data into smaller packets, sending them to their destination, and making sure they arrive safely. TCP accomplishes this by including a header with each packet that contains information about the packet, such as its destination and the order in which it should be received. If a packet is lost or corrupted during transmission, TCP can request that it be retransmitted. The Internet Protocol, IP, is responsible for routing the packets to their destination using unique IP addresses. Each device on a network is assigned a unique IP address, which acts as a sort of mailing address and allows the IP to route packets to the correct destination. Together, TCP and IP work to ensure that data is transmitted efficiently and reliably between devices on a network. How TCP IP works. The sending and receiving of data packets. When a device sends data over a network using TCP IP, the following process occurs. 1. The sending device breaks the data down into smaller packets, each with a header that contains information about the packet, such as its destination and the order in which it should be received. 2. The sending device sends the packets to the destination using the Internet Protocol, IP. The IP part of TCP IP is responsible for routing the packets to their destination using unique IP addresses. 3. The packets are transmitted over the network, potentially passing through multiple intermediate devices such as routers, before reaching their destination. 4. The receiving device receives the packets and uses the Transmission Control Protocol, TCP, to reassemble the data in the correct order. TCP also checks for any errors or lost packets and requests retransmission if necessary. 5. The receiving device processes the data and, if necessary, sends a response back to the sender using the same process. In this way, TCP IP allows devices to communicate and exchange information over a network in a reliable and efficient manner. Part 2: How TCP IP powers the Internet. In Part 2 of our exploration of TCP IP, we will look at how this protocol powers the Internet and enables the communication and exchange of information. From sending emails and accessing websites to using social media and streaming video, TCP IP plays a crucial role in how we use the Internet. We'll also delve into the role of IP addresses in routing data packets to their destinations, and unpack how IP addresses enable devices to connect and communicate. Let's dive in and learn more about how TCP IP makes the Internet work. TCP IP is used when you send emails, use social media, or while you are streaming this video. TCP IP is used in a wide range of applications and services that rely on the Internet for communication and data exchange. Here are a few examples of how TCP IP is used. 1. Sending emails. When you send an email, your computer uses TCP IP to connect to an email server and transmit the message. The email server then uses TCP IP to route the message to its destination. 2. Using social media. When you post a message or photo on a social media platform, your device uses TCP IP to connect to the social media server and transmit the data. The server then uses TCP IP to store the data and make it accessible to other users. 3. Streaming video. When you stream a video, your device uses TCP IP to connect to a streaming server and request the video. The server then uses TCP IP to transmit the video data to your device in small packets, which are reassembled and played back by your device. In all of these cases, TCP IP is used to establish a connection between devices and transmit data packets efficiently and reliably. It is an essential component of these Internet-based services and allows them to function smoothly. The importance of IP addresses and how they work. IP addresses are a fundamental part of the Internet and play a crucial role in how data is transmitted and routed between devices. An IP address is a numerical label assigned to each device connected to a computer network that uses the Internet Protocol, IP, for communication. It serves as a unique identifier for each device and allows it to be distinguished from other devices on the network. IP addresses are formatted as a series of 4 numbers separated by periods, such as 192.168.0.1. Each number can range from 0 to 255, and there are over 4 billion possible IP addresses. IP addresses are used by the Internet Protocol, IP, part of TCP IP, to route data packets to their destination. When a device sends a packet of data to another device, it includes the destination device's IP address in the packet header. The IP then routes the packet to the correct destination using this address. In addition to identifying devices, IP addresses are also used to identify networks and subnetworks. A network is a group of devices that are connected and can communicate with each other, while a subnetwork is a smaller group of devices within a larger network. IP addresses can be used to identify which network or subnetwork a device belongs to and route packets accordingly. In summary, IP addresses are important. IPs allow devices to be identified and connected on a network. They enable data to be routed to the correct destination. They are a key component of the Internet Protocol, IP, and the TCP IP protocol suite, and are essential for the smooth functioning of the Internet. Thank you for watching video 1. Watch the conclusion in video 2 where we finalize and summarize this discussion and also discuss additional protocols like HTTP, FTP and